Hey, good morning, guys. Today is Friday, the 22nd here, May 22nd. We're going to be doing 413, 416, and 418, 416, 417, 418 today. I will not be online today for support. I'm sorry. I'll be back on Tuesday because Monday is Memorial Day. Enjoy your weekend. Don't fall behind, guys. Keep up with this stuff. Do the best you can to keep up. And, you know, we got this. We got this, okay? These skills here we're talking about are going to be really important to develop for moving into next year and things like that. So we're going to go ahead and dive right into this here. Okay, so it says tiling a rectangle to find area. Okay, well, one thing we see right away with this problem as we read it here, you're going to find that it says this one's a little bit different than the ones we've been doing in the past. It says a rectangular postage stamp has a length of 3/2 inches and a width of 3/4 inches. What is the area of the stamp in square inches? So immediately you see that this is greater than a whole, right? Okay, and over here we have a width of 3/4 inches. So what we want to look at here is, as we model this and think about what this looks like, we want to start with one whole, right? We want to start with a whole because everything is in relationship to a whole. So if this is 1, if this is 1 by 1, if this is 1 by 1, one side we're going to need 3/4, right? We're going to need 3/4. So let's go and break this up into 1, 2, 3. A smarter person would have used the lines and made it look really nice, but I'm not a smarter person. Okay, so 3/4, right? On this side here, up here, this is 1, right? But wait a second, we have 3/2. Let's go ahead and make just 2/2 first, right? So this is a half. This is a half, right? But we need 3/2. We need 3/2. So what I can do is I can just make another whole stamp here, right? If I make another whole stamp, then I cut this here, now I have another half, right? Does that make sense? So I'm going to go ahead and extend this all the way across over here. So technically this is another one, okay? And this is 1 by 1 as well, right? Okay, but this whole thing isn't one. The idea is we're going to be cutting this. This is just 2 separate ones. Now, we only need 3/2, don't we? We need 3/2. We don't need this one over here, but we're gonna leave it there. I'm gonna go ahead and shade this in to show my 3/2 here. So this green section are 3 complete halves. So 1/2, 2/2, 3/2. So that shows my 3/2. I'm not going to shade this one because I'm not using it. Okay. Now, this is right here. It's going to be 3/4. 3/4 going this way, right? I mean, I'm not using this as part of my halves, right? So this would be 3/2 of. This would be 3/2 of 4/2 or of 2 wholes, right? Okay. So this one I'm going to do 3/4 of all this. So I'm not going to use this bottom one because it's not part of the 3/4. So I'm just going to do this whole thing here. Okay. Now, like we've been talking about with the area model, the important part is the overlapping, the parts that have like a lattice look and overlap these colored areas, right? So we have these spaces here, and there's 1, 2, 3, 4, 5, 6, 7, 8. There's 9 of them, right? There's 9 of them. So if my problem is length times width, right? Length times width equals area. And I know let's say my length is 3/2. My width is 3/4. Okay. So if I know that this is the multiplication problem I'm looking at here, I'm looking at this as multiplying here. So I know that there's going to be nine parts being represented, right? Okay, so that's great. So that means I'm going to have 9 parts. The only problem with this is that we are not going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 and say it's 9/9 because that's not true. Because we got to remember, everything's got to be represented in relationship to one whole. So remember, this is one whole. this is one hole, right? So that means if I just focus on just this one hole, how big are each of these parts of this hole? Well, this part right here is one part of 2, 4, 6, 8. So what I'm dealing with in the hole, all these pieces are all the same size. All of these pieces here are eighths because there are 8 parts, 2, 4, 6, 8, right? So therefore, that one right there is 1/8, that's 1/8, that's 1/8, that's 1/8, and so on and so forth, right? So when I include all of the pieces that are overlapped, I just have more pieces of more 1/8 pieces. So I can look at it from this standpoint. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 parts, and each part is 1/8. So therefore, 9 times 1/8 equals 9/8. Okay, and so that would be our answer. Now that is an improper fraction. We'll need to fix that in a second here. Okay, but if we look down at, we talk about using our multiplication strategy here, we know that 3 times 3 equals 9, correct? And 2 times 4 equals 8. And that gets us to the same place, right? So using that quick shortcut is really important. But this is really important for us to understand why this is happening. Why are we able to get this answer? This is my evidence why. This is my model to show why. This is not the only way we can model it. You'll have a chance to look at page 414 to look at some other different ways you can look at and model it. You could break it up as just 2 separate holes. So instead of kind of connecting like I do, you can just draw them as 2 separate ones. You know, so it'll be 3/4 of this half over here and then 3/4 of a hole. Okay, there's a lot of different ways to think about it. If we also think about this way, because this is one hole, right? Because this is one hole, we always think, well, 3/4 times 1 is 3/4, right? You know, and then we can think about this as, oh, well, that is 3/8, and then we can convert 3/4. Then we can do 3/4 plus 3/8, and then we'd have to convert this, and this becomes 6/8 because we have to multiply each one to get to the eighths, right? Like we've done before, and that would equal 9/8 as well. So there's a ton of different ways we can approach this, right? At the end of the day, the easiest way is going to be just to multiply across, but I want you to make sure you understand why we multiply across. What is happening when we do it that way, okay? Now, we're not done yet, are we? We need to convert this into a mixed number. Again, there's a lot of ways to look at this. I'm just going to look at it this way. Again, remember, this is a half, this half, so this is one whole here, right? Okay, over here, this is one whole. I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8, 2, 4, 6, 8, right? So if I took these two pieces, in order for this mixed whole, if I took this piece here and I moved it over here, I took this piece here, moved over here, I would essentially be making a whole, right? Okay, so if I move this over here, I move this over here, now I filled in that one hole. Now I have one hole. What's left over? Well, 1/8, right? 1/8. So the best answer is going to be 9 1/8. Okay. Try not to leave things as improper fractions. Convert them to mixed numbers and to their simplest forms. Obviously, we can look at it this way: that 9/8. Okay. We can break this up into a group of 8/8, which is equal to one whole. Okay. What's left over? Well, if I take 8/8 away from 9/8, what's left over is 1/8. Right? So if I go and decompose this number, again, 8/8 is equal to 1. 1 plus 1/8 is equal to 1 1/8. Okay? All right. Like I said, if you look on these next pages here, you can look at some other examples of ways to show it and ways to think about it, okay? I do not have a schedule to work on this page. If this connected stuff helps you looking at it, then do it. I kind of covered most of this stuff already in my discussion. So if you're watching the video, then most of it's covered for you, okay? So what we're going to be looking at now is looking at doing pages 416 to 418, okay? So I'm going to go ahead and do a couple of these with you to try to get us a little more practice in doing this and getting a little bit better at this, hopefully, okay? It says Bernice's rectangular math book is 2/3 foot wide and 5/6 foot long. What is the area of her book what is the area of a page in her workbook? Okay, so if her workbook is 2/3 of a foot, wide, that's my width, then 5/6 of a foot long. Okay, what is the area? What is the area? Then we're going to be multiplying length times width, right? Sweet. So it's going to be length times width. Okay, so this is my W. We're going to multiply this by my length. Again, that's going to give us the area, right? That's going to equal area. Okay. So again, if it's going to be, and again, these are interchangeable, so I'm just going to write 2/3 times 5/6, because again, it could be length times width or width times length. Doesn't matter which order you say it in. Okay. So now, as we talked about, if we multiply across here, 2 times 5 is 10. Okay. 3 times 6 is 18. And it gets us to 10/18. Okay. We should simplify this. Okay. We should simplify this. And if we're going to be simplifying this, we need to consider, again, this is going to be, these are, we could draw a model out for this as well, but I don't think we need to draw a model for this if we just multiply across here. So we get 10/18, which is great. Okay. But we can't simplify this. How do I know we can simplify this? Both these are even numbers. That's the first thing. They're both even numbers, so I know I can divide each. I can divide this by 2 halves. Again, I'm dividing it by 1 whole, which is keeping the equivalency, right? So I'm not changing the value here. So that becomes 5/9. Okay, because 10 divided by 2 is 5, 18 divided by 2 is 9. So we get to 5/9. Okay. So again, both of these answers are correct. The book actually only has this as an option, but why wouldn't we go further? Like, it doesn't make any sense to not go further. Okay. Number 8 here. Obviously, pause this video if you need to, if I'm going too fast for you, if you need to rewatch things. Show one way to use tiles to find the area of the rectangle below. What are the lengths and widths of width of one of your tiles? What is the area of the rectangle? So what are the lengths and widths of one of your tiles? So we have here what is one of the little sections. One little section we break up. So as we break this up, we clearly have 4/5 here, right? This one is 7/5. So again, this is already greater than 1. So we're going to have to keep that in mind here, right? So if I break this into 4/5, I'm going to go ahead and go 1, 2, 3, 4, right? And here's going to be my 4/5, correct? Okay. And then over here, I'm going to go ahead and break this into fifths as well here, because I'm going to have fifths, but I'm going to have 7 of them, right? So if I go 1, 2, 3, 4, right here, this box that I made so far, here is 5/5, right? This is 5/5 here, right? So in order to make 7/5, I need 2 more parts, right? But this is 1 whole, correct? This is 1 whole. And that's why this is important. So I'm gonna need 2 more fifths here. So I'm gonna go ahead and this is my 2/5 here for a total of 7/5, let's say. Okay. I didn't use the whole entire thing, I guess, so I kind of screwed that up, but it's going to serve the same purpose. Okay. If I would have used the whole thing, well, let's just go ahead and say, let's just say I don't need that. When you do yours, try to use the whole thing. I didn't plan mine out very well, and I'm using markers, so I can't really erase like I would like to. Okay, so we have 1, 2, 3, 4, 5. Oops, 1, 2, 3, 4, 5, 6. I did do it right. I just messed up in my counting. Okay, so I did mess up. 1, 2, 3, 4, 5. So here's my 5/5, and these are going to be my two more fifths in their size, right? So we are going to use this one over here. I messed it up. I apologize. So the 7/5 is this whole thing. Okay. So the question though is, how big is 1 square here? 1 tile. So if this is a tile, how big is this 1 tile here? Well, it's got to be in relationship to a whole, right? So if we think about this as fifths by fifths, okay, that means it's going to be fifths by fifths. So if we hold off these side 2 fifths that are over here, 5/5 here, right? So it's fifths by fifths here. There's a total of 25 because it's 5 by 5, right? So that means that each one is going to be the width of your tiles, each tile is going to be 1/25th, right? Each tile, like this little tile right there, is going to be 1/25th. All right. Well, how many tiles do I have? So let's look at this. How many tiles do I have? Well, I know I have 5 by 5, right? So that's 25 tiles. But then I have 2 more over here, right? I have 2 more over. So I have 1, 2, 3, 4, 5. Oops, sorry. I don't want to include these down here. So I only want to include. I don't want to include these ones down here, right? I only want to include these ones up here, including these ones I scribble out over here. I'm sorry about that. I'm just going to do this. I messed that up. So these ones over here. So with these bottom row, this whole bottom row here, I'm not using, right? Because that would be 5/5. I want 4/5 of it, right? But this tells me the size of it. So, but now how many do I have? I have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. This is a full 7 by 4 array. So there's 28 there because 4 times 7 is 28. So I have 28 of these squares. So that'd be 1/25 times 28, which is going to give me 28 25ths, which is going to be equal to, again, if I take 25 away from this and make a hole here, that has 3 left over, 3 25ths left over, right? Okay, and so if we go on and prove this by using just the multiplication of multiplying it across, this equals 28 on the top, 25ths on the bottom, right? Okay, whew. Sorry about that. Hopefully that makes more sense, but I'm just proving that we can multiply across. Obviously, I would need to adjust that one as well as we move forward. Okay, number 9. Jonathan's rectangular post is 7/4 yard in length and 2/3 yard in width. What is the area of John's post? Okay, well, let's not overthink this. We're talking about area. We have length and we have width, right? Okay, so then I know I have 7/4 length times 2/3 width, and that's going to give me my area. I want to know what is the area. I want to solve for area, so I'm just going to do this. 14/12, right? I look down on my options here. That's the only one that's makes sense. Even if I converted this to 1 and 2/6, then that would be equal 1 and 1/3. Okay, there aren't any options over here for either of those other ones, so that's our only answer. Okay. Your task today, you have 2 pages here. You have 17, 417 and 418 here. I'm going to have you do those on your own. Okay, that's your task. I will see you on Tuesday. Okay, and have a great weekend. Memorial Day, so keep people in your thoughts, and yeah, take care, guys.